Welcome to homework.
This is chapter 21, problem number 12. We have a solenoid that has 600 turns and the length of it is 25 centimeters and the diameter of the solenoid is 2.5 centimeters. And we have another coil, let's call it, and the number of turns is 14. It's a much shorter one. It's tightly wrapped around the solenoid, which means they're going to share the same diameter of 2.5 centimeters. Now, if the current in solenoid is actually changed from zero, let's say the initial current in the solenoid is zero, and then it's increased to a current of 5 amps in 0.6 seconds, then what is the induced EMF in the coil? So, in the short one, what is the induced EMF in the coil? Now, if we're looking for the induced EMF, let's say the magnitude of it, as you know, this is gonna be equal to the change in the flux with respect to time through that coil. And flux is, for one wrap, is gonna be B times A, but we have N2 of them. So we're gonna have N2 times B times A, right? N2 times B times A. Now, what's changing and what's not changing for the coil is that, well, N2 definitely is a constant. You can take it out of the delta or here, right? The area is definitely constant. What's changing is the B field that the coil, that is passing through the coil, is changing with respect to time, right? So let's think about the source of this magnetic field. The source of the magnetic field is actually coming from the solenoid, right? So let's remember the magnitude of the magnetic field generated by a solenoid. It's going to be mu naught times N1 though, right? The number of turns in your solenoid times the current passing through the solenoid divided by the length of your solenoid. Now all we need to do is put this equation back in the induced EMF equation for the coil. Now N2 times area, well, let's write it in terms of pi d over 2 squared, right? This will be the area, times delta over delta t, and let's plug in for B mu naught N1 I over L1. Now let's see what's constant here. Mu naught, let me rewrite everything here. We have pi d over 2 squared, the area. Now mu naught is a constant, N1 is constant. It's not changing with respect to time. L1 is not changing with respect to time. However, the current is changing with respect to time, right? So then induced EMF in the coil is going to be N2, which is 14 times 3.14 times d over 2 squared. So d being 2.5 centimeters, but we're going to convert it to meters, right? Over 2 squared times mu naught, which is 4 pi, right? So let me write it up in the 3.14. 4 pi times 10 to the power of negative 7 times N1. N1 is 600 times delta I. Delta I is, so if we're going from 0 to 5 amps, then delta I is going to be I final minus I initial. So 5 minus 0, it's going to be 5 amps, right? In the denominator, we have L1, which is 25 centimeters. Let's convert that to meters, then it's going to be 0.25 meters, right? And delta T. Again, delta T is given to us as 0.6 seconds, right? So when we plug everything in, what we find for the induced EMF in the coil is 1.73 times 10 to the power of negative 4 volts.